overarching theme of transformations. Do you know what a transformation is? Like if we say someone underwent a transformation, what is that? Like a change, right? They transformed, they changed. Think of, my kids love Transformers, right? Like the car that becomes the robot and that type of stuff. It changes, it's a transformation. So what we're gonna do is we are going to talk about several different types of transformations, but the first half of today is just the idea of a transformation. The second half is the first of the different transformations we'll talk about, okay? So you're kind of going to get a little bit of both today. Okay, has everyone found the notes? No. Go to modules, chapter 9 notes. Good now? Here we go. Okay, so a transformation, we call it a mapping. When you see a mapping, it's basically I took this and I put it here. I took this and I mapped it onto this other place, okay? So it's a mapping that results in a change in either the position, the shape, or the size of some figure. Okay, so it can change the position of it, the shape of it, or the size of it. I'm going to give you 3 of the basic transformations we're going to use. This isn't the only 3, but these are the 3 that kind of you'll piece together to make other ones as well. Okay, so the first one is a flip. We say you reflect. You flip it over some line of symmetry, essentially. So if I were to flip this triangle, oh, I wonder if I can do that on here. I don't think I can. You might be able to do it in Notability. Take a little screenshot of this and flip it. I don't think I can flip. I think I can maybe rotate. I don't know. But a flip would look like this. Basically, I'm saying, here's this line of reflection. My flip would land me over here. Okay, it just flips over some invisible line that we have. Okay, so that's a flip. A turn, another name for that is the rotation. So the ones in parentheses, those are like the math word for it. The other one is the one that you probably already know. So turn is to rotate something. So we would take this triangle and we would just rotate it. Think of like a doorknob, right? You turn a doorknob, you rotate a doorknob. Our rotation would land us with something like, this isn't going to fit here because my triangle's too big, but that's okay. Something like that, right? It rotated. And then the last one is called a slide or a translation. So we're going to translate it to a new place. What's up, Copper?
Is it always a left turn?
Oh, that's a great question. We are going to, if they don't specify, we are always going to go counterclockwise. But we'll get into that when we get into rotations. But yes, that's an interesting observation. So a slide is take that figure and just slide it to a new spot. So like this spot right here, for instance. Okay, so you have a flip, you have a turn, and you have a slide or a reflection, rotation, translation. Okay. Okay, then just a few terms to make sure that you know, because these are really easy to get mixed up when you're setting these up, and we want to make sure we have the right thing. So the pre-image versus the image, okay? What do you suppose the relationship is there? What's the pre-image? Before, right? The pre-image is the one you started with, so it's the original figure. Okay, the image is your resulting figure, your new figure. They call it a resulting figure. I don't care if you call it the new figure, that's fine. So you start with the pre-image, you end at the image. Okay, and then the last thing, and we don't do a ton with this, but we will address it from time to time, it's called a rigid motion. And a rigid motion just means that a transformation preserves distance and angle measure. Okay, distance and angle measure. In other words, it's going to stay the same size. Okay, a rigid motion is just going to stay the same size and shape as it was. Okay. Basically, the distance between any 2 points is the same, and the measure of each angle, your corresponding angles are going to be congruent. Okay. Okay, so look at example 1 here. It says, does the transformation appear to be a rigid motion? Explain. So based on that definition I just gave you, preserves distance and angle measure. So same size, same shape. Would you say letter A, your pre-image being the left side, your image being the right side, does that look like a rigid motion to you? Yeah. We would say yes, because it preserved distance and angle measure. I'm not going to write that. I'm going to do this because I'm being a little bit lazy. Okay, it's a yes because it preserves distance and angle measure. What about letter B then? Is that a rigid motion? That's a no, because it doesn't preserve distance and angle measure, right? So if it's the same size and shape, yes, rigid motion. If it's not the same size and shape, not a rigid motion. Okay. All right, and then a couple little symbols that you're going to need to know. Whenever I say something maps onto, the symbol that they're going to use for that is just an arrow. So they'll say like triangle, like for this picture, triangle JKL maps onto triangle. And then the other term that you need to know is prime. Prime is always just going to be a little hash mark. So we would write this as triangle J prime, K prime, L prime. You can kind of see, oh, not L, Q, sorry. I just assumed L. Those are Q's. JKQ maps onto J prime, K prime, Q prime. Okay. Yes, ma'am.
What exactly does it mean when something maps onto something?
So you have a pre-image, and then it maps onto the image. It like becomes that new image. So like this one reflected, right? It mapped onto it by reflecting to the new spot. It's basically just saying this moved to this place. Yeah, copper.
What's a prime?
Prime is the little hash mark. When we say prime, it's that little hash mark. It's basically saying this was your pre-image, right? The J is your pre-image. The J prime is your image. It's what it became, right? So whenever it has the prime, that means it's the end figure. It's what your figure ended as. Okay. Okay, so example 2 here. It says triangle ABC maps onto, right? That's what we say for the little arrow. Triangle A prime, B prime, C prime. So you're starting, your pre-image is what figure? ABC. This one's your pre-image, right? A prime, B prime, C prime is your image. So this is pre, this is image. Okay. What it says is what are the images, in other words, what are the new angles of angle A and angle B? So what is the image of angle A? Here's angle A right here.
A prime.
The new image is A prime. Okay, so you're just matching up corresponding parts, which when they use the same letters is glorious, right? Because A becomes A prime. So A prime would be the image of A. What's the image of B?
B prime.
B prime. Okay, so it's just what they became. It feels a lot like congruent figures when we talked about like congruent corresponding parts in triangles, right? It's very similar to that. Now we're just adding that little prime hash mark to it. So then we have corresponding sides, okay? Which sides match up? And again, this is very similar to matching up corresponding parts in triangles. So I would say segment AB, and what segment are corresponding sides? A prime, B prime. Okay, so AB corresponds to A prime, B prime. BC corresponds to B prime, C prime. And AC corresponds to A prime, C prime. How are we doing so far? Okay. So that's technically our first lesson. That's the 9-1A lesson, but because it's a block day, we're doing 2. So 9-1B is going to just address the different types of transformations and start with what is that first one we're going to talk about, okay? Do you need a break? It's only been 10 minutes. Are you okay? Can we just keep going? Okay, we're going to keep going. So with this second part, we already kind of talked about this. The types of transformations that we will do. We said you translate, you reflect, you rotate. So the names of those are a translation. That was the slide, right? It just slid to a new spot. There's a reflection. What was the word we used for that? A flip. Okay. And a rotation. And that one was the turn. Okay, so we're going to talk mostly about those 3. There's a couple other types of transformations that we'll talk about that aren't rigid motions. And then there's one that combines some of these. But for the most part, these are the 3 we're going to focus on. And the one we're going to start with is the translation. So we're not going to cover reflection or rotation at all today. We're just going to stick with translation. I would say translation's probably the easiest one, in my opinion. We're just going to slide, okay? So a translation, here's what it says. It maps all points of a figure the same distance in the same direction, okay? So let's call this triangle right here, triangle ABC. A slide is going to take that, and however far I move B to B prime and A to A prime and C to C prime, it's going to be the same distance, okay? So this is what it looks like. You'll have B to B prime, A to A prime, and C to C prime, and all of those lengths will be the same. Remember, that's how we mark things congruent here, right? A translation is a rigid motion. So it's going to be whatever the figure started as, it's going to stay that same figure, and we're just sliding it. So it doesn't grow, it doesn't shrink, it's exactly the same figure, meaning that angle B is now congruent to B prime, angle C is congruent to angle C prime, and angle A is congruent to angle A prime. Okay, so they are congruent figures. That also means that AB is congruent to A prime, B prime. BC is congruent to B prime, C prime. And AC is congruent to A prime, C prime. I don't know why I put 2 on the first one. You can put any number you want as long as they're consistent. So the triangles are congruent. Everything about them is the same. It just slid to a new location, but the distance every point slid is the same distance. Okay, that's a translation. Okay, so how we write a translation is like this. You're going to have 2 triangles, okay? Triangle ABC, triangle A prime, B prime, C prime here. Basically what's happening is you have to figure out how far we had to move to get from point A to A prime, okay? Or point B to B prime or point C to C prime. Because it's a translation, it will be the same for all 3 of them. So pick one set of points. Do not do all 3. You don't have to do all 3 if you know it's a translation, okay? I'm going to go A to A prime. I just told you what I was going to ask you. You always start at which one? Not the prime, right? Just the general letter without the little hash mark. That's your pre-image. So start there and move to the other one. So let's think about this. If I'm at A and I want to get to A prime, I'm going to go 1, 2, 3, 4, 5 to the right. And then I'm going to go 1, 2, 3 down. That means for every set of points, that's what I did. I went 5 to the right and 3 down. Basically what I'm saying is take your X value and add 5. Take your Y value and subtract 3, right? If you're going down, it's subtraction. If you're going up, it's addition, okay? Okay, so here's how you write a translation. You say, translation's always gonna be a capital T. So it's a translation. And then we put these funky little pointy brackets down here. And that's what tells us where to move. So it's going to be a positive 5 for our X because we moved 5 to the right. And it's going to be a negative 3 for the Y. Okay, so this is where you're moving on your X axis. This is where you're moving on your Y axis. Okay, and then the way you finish it is you say it's a translation of 5, negative 3 of triangle ABC becomes triangle, and really if you want to use maps onto there, you could too. A prime, B prime, C prime. I'll give you a second to catch up because that was a whole lot of words and writing and whatnot. Any questions on that so far? Whitney.
So does X represent A and then Y represents A prime?
No. So X and Y here, right? That's like our starting point. And then these are telling us where we're moving from the starting point. So you have your X and Y. We're moving 5 to the right and 3 down for every set of points that we have. Does that make sense? Okay, I think it'll make more sense when we do this part right now. So let's take a look at this. Yeah, Luke.
So why wouldn't we use arrows when we're talking about triangle ABC, and then arrow, triangle?
You can. You may use an arrow here. I often just put an equal sign.
Okay.
But yes, technically it is mapping onto the new one, so the arrow is great.
Okay.
Yeah. Okay, here we go. Example 3, it says, what are the vertices of, and now I'm just going to write this so that you see how to say this, right? What are the vertices of a translation, right? T is always translation of negative 3, 4 of triangle ABC. Okay. So it says, what are the vertices of a translation of negative 3, 4 of triangle ABC? So the first thing I would do on these, there's a couple ways you can do it. I like to graph it first and then just translate on my graph. You don't have to, but you are eventually going to graph it. So I just graph it as I go. That's up to you. But the first thing you want to do is you want to graph this. Okay, so step 1, graph triangle ABC. So 3, 3, 1, 2, 3, 1, 2, 3, 5, 1, 1, 2, 3, 4, 5 to the right, 1 up. Oh, and label them as you go. This is A, this is B, and then C is 1, 0. This is C. Okay, so that's step 1. Now, your step 2, you have a couple options. If you want to, you can take these points, 3, 3, and do this to it. So 3 minus 3, right? 3 minus 3. And then this 3 plus 4, and you'll get your new point, and then plot that. In my head, that's just not the way I do it. You may do it that way. If that makes more sense to you, go for it, okay? If you want to come up with A prime is So it would be 3 plus the negative 3, comma, 3 plus 4. So A prime is going to be 0, 7, okay? Again, not the way my brain wants to do it. My brain wants to do this because I just think it's easier. If I have a translation of negative 3, 4, where is a negative 3 moving me?
Sideways.
This is your X, right? So left 3. This is your Y. That's a 4, not a Y. It looks like a Y. 4 is moving us where? Up 4. Okay, so what I do is I say with a translation of negative 3, 4, I'm going to go 1, 2, 3 to the left, 1, 2, 3, 4 up, and that's my A prime. Okay, then I'm going to do it again. Letter C, 3 to the left, 1, 2, 3, 4 up, and that's my C prime. And then I'm going to do it again. 1, 2, 3 to the left, 1, 2, 3, 4 up, and that's my B prime. So my new triangle looks like that, okay? If you don't like to do that on the graph for each thing, I don't ever ask you to name those points. I just ask you to graph it. So if you would rather name the points first and then graph them, that's fine, but you don't have to do that, okay? If you wanted to keep going with that, you could over here say B prime then is going to be 5 plus a negative 3 for your X value, and then 1 plus 4 for your Y value. So your B prime should be at the point 2, 5. Well, if you look over here, my B prime is at 2, 1, 2, 3, 4, 5. So you can get there either way. I just think it's quicker and easier to just take this and graph it. Just shift it where it needs to go, okay? Are you like in agreement on that, or do you like it better the other way? I'm just curious. I don't ever ask. I always just teach it my way. But this year I thought I'm going to present it both ways, and maybe there's different opinions. Just graph it?
Yeah.
Okay. That's the way I'm going to do it in class. I'm just going to graph it. But if you want to see it a different way, just ask me, and I will show you the other way. Okay? Okay. Example 4 is a little bit different. Now it says, what's the rule that describes the translation that maps triangle LMN onto L prime, M prime, N prime? This word right here should be your, like, I need a rule. Whenever they ask for the rule, they're asking for this. Okay, this is your rule, if you will. Okay, so you're going to write a rule for a translation that takes this triangle onto this triangle. So the first thing you want to do is you want to graph them both. So L is at negative 4, negative 1. And it's super important that as you graph these, you label them because you need to see what corresponds to what. Okay, so that's point L. M is at negative 5, 1, 2, 3, 4, 5, negative 3, 1, 2, 3. So that's M. And then N is at negative 2, negative 2. So that's N. So here's our first triangle. Probably should have put my L over here. Okay. Our next triangle, so L prime, M prime, N prime is at 2, 2. So that's L prime. M prime is at 1, 0. And N prime is at 4, 1. We need to write a rule. What's that rule going to start with? A T, right? This is a translation. It's a slide. So that T tells us translation. Reflection and rotation are capital R and lowercase r. So it's always going to be the letter of the thing we're talking about, okay? This is a translation. And then we have to define what is that translation? Where are we moving? So you put your pointy brackets, and then you say where we moved. Now, anyone think they can come up with what that is? What'd you get? positive 6, positive 3, right? So from L to L prime. Now be careful. Don't go L prime to L. You always want to start at the one that doesn't have the hash mark and move to the one that does. You don't have to do it for every point. Pick one set of points. So I would start at L, and I would go, okay, it's 1, 2, 3, 4, 5, 6 to the right. And it's 1, 2, 3 up. So that's where we're moving for every set of points. It's a translation of 6, 3 of triangle LMN that maps on to triangle L prime, M prime, N prime. Okay, when they ask you for the rule, that's the rule. Questions on that? Are we keeping up? Do I need to slow down? Okay. Last thing, and then we're done. Quick day. Hooray. I would love to give you your test back, but I can't because a lot of people haven't taken it yet, so sorry. But I'll give them back eventually. Last thing is called a composition of transformations. Maybe you've been into music, right? Compose. If you compose music, you're putting all this music together to make this beautiful song, right? A composition is just taking different transformations and putting them together, okay? So it's going to undergo multiple things, multiple shifts, multiple flips, turns, whatever. So this is 2 or more transformations. In our case, we're just talking 2 different slides, really, from this setup. So here's the problem. It says, example 5, Carmen leaves her apartment. Okay, so we're going to call her apartment home base, 0, 0. Okay, that's her apartment. Leaves her apartment and travels 2 blocks east and 5 blocks north to the library. What quadrant will you be in?
The positive.
The first one, positive, positive, right? 2 blocks east, so that's going to go 2 blocks east, 5 blocks north. 1, 2, 3, 4, 5. Okay, so this right here is the library. Then she travels 4 blocks west and 1 block south to the grocery store. Where are we moving from? The library. She's at the library right now, and it says then she did whatever she did. So from the library, she's going to go 4 blocks west, 1, 2, 3, 4, and 1 block south to the grocery store. The question is, and this one always throws people for a little bit of a loop. Think about what this is asking. Where is Carmen in relation to her apartment? So where is she now at the grocery store in comparison to where she was at her apartment?
2, -4, right? Or like having
2 west, 4 north.
She's 2 blocks west. And what?
4 north.
4 blocks north. She is currently 2 blocks west and 4 blocks north. Okay? It's tempting to say 2 blocks east and 4 blocks south, right? But that's not where she is. That's where she, like, compared to where she started, that's where she'd have to go to get back to her apartment, right? So just pay attention to the wording on that. She's 2 blocks west, 4 blocks north. Good to go. Yes, thank you. Where are you going? ASB?
Probably to the ASB room.
Okay. Questions on that at all? Okay.